Williams Ecopedia, Volume 1, Topics in Sustainability from Arcology to Xeriscaping, copyright June 2010. This book is dedicated to all the pioneers who have and still are working hard to lay the foundations for a sustainable future. With special thanks for all the pioneers from Arcosanti, the Ecosa Institute, and the Lost Valley. The security of people and nation rests on four pillars: food, energy, water, and climate. They are all closely related and all under increasing stress. Tom Burke, the ENDS Report. I know the human being and the fish can coexist peacefully. George W. Bush. Aquaponics. Aquaculture is the practice of growing fish in a controlled fish farm and is the standard in the fish industry. Many people are also familiar with the concept of hydroponics, growing plants in a controlled greenhouse or other facility. There's a new sustainable option to both of these practices that is widely gaining in usage, and it is called aquaponics. In any fish farming operation, the water for the fish must be purified of fish fecal matter, free-floating planktons, and other waste products. In a hydroponic system, nutrient-rich fertilizer for the plants must be added to the water to ensure healthy growth. To quote Dr. John Todd, inventor of living machines and founder of Ocean Arcs International, which pioneered aquaponics, in nature, there is no waste. In nature, all waste from plants and animals becomes fertilizer and nutrient for plants, which in turn becomes food for animals. The plants and animals can then become food for humans. I apologize to any vegans out there. Starting in 1971, the New Alchemy Institute began experimenting with techniques for recycling the wastewater, called effluent, from fish farming systems into hydroponic systems. The effluent from the fish tanks provided all the nutrients the plants of the hydroponic systems required. The process of digesting the nutrients from the effluent had the effect of cleansing the water, and the cleaned water could then be cycled back into the fish farm. Not only that, the hydroponic system could be used to grow plants edible for the fish, meaning the system produced the food for the fish from the fish effluent. This arrangement created a self-sustaining closed loop functioning much in the way that nature does. When aquaponics was first introduced by the New Alchemy Institute, there were many skeptics who did not believe the system could provide enough food for the fish, would be incapable of keeping the water sufficiently clean, and would be prone to disease in both the fish and the plants. None of these have been the case. Aquaponics systems have been shown to provide clean water without the aid of artificial cleaner systems. They also use far fewer resources in terms of overall water used, and they require little to no outside feed to be brought in. They are cheaper, cleaner, more environmentally friendly, and healthier than standard aquaculture practices. Not only does the aquaponics system produce fish as an edible product, it can also produce plants edible by humans. The human diet is very complex and needs to be balanced with many factors of nutrition. By producing fish as a protein source and plants for other nutrients, a single aquaponics system can provide a completely balanced and healthy diet. Even for vegetarians, the aquaponics system still provides many advantages. The aquaponics systems at the New Alchemy Institute were made with techniques very similar to the design of living machines. Living machines use all natural processes to clean and recycle water. It was the exact same natural forces at work in living machines which worked for an aquaponics system. An aquaponics system basically takes two tanks, also referred to as ponds. One pond holds the fish. The water flows from that pond into another, holding the plants. Both tanks should have a layer of mud at the bottom. To create a more robust system, extra tanks and water features can be added to the design of the system. There are two main tricks that must be designed into an aquaponics system: flow and aeration. The water must be kept flowing, not necessarily 24 hours a day, but for most of the day. The flow rate needs to exchange all the water in the fish pond for all the water in the plant pond about every 2 to 3 days. This flow rate can be accomplished with one simple pump, and that pump can even be solar powered. The ponds are connected by pipes. Standard PVC pipes will do. Water is pumped from the final tank and flows through a trough where it falls into the first tank, which pushes the water from the first tank into the second. Aeration provides oxygen for the fish and helps to maintain the full metabolic efficiency of the plants and microorganisms to clean the water and break the effluent down into nutrients. Aeration can be provided by two means. The first is by air pumps placed into the ponds. Aeration can also be provided by tumbling water, water that flows and falls in ways similar to small waterfalls or babbling brooks. Tumbling the water not only helps to aerate, but also helps to grind apart solids suspended in the effluent. An aquaponics system should use both methods of aeration for maximum efficiency. Tumbling provides aeration and additional cleaning, and if designed with a keen aesthetic eye and good craftsmanship, it can produce fountain-like water features that both look and sound beautiful. Combined with the plants in the ponds, the entire aquaponics system can be a beautiful feature. The water of an aquaponics system must be kept warm for the health of the fish, the health of the plants, and the efficiency of the cleaning. At the New Alchemy Institute, they built what they called solar ponds, heated by passive solar design. Solar ponds were built inside of clear fiberglass tanks, positioned so they'd be exposed to direct sunlight, and the sunlight would heat the water of the tanks without the need for artificial heating elements. Some systems have used artificial heating elements powered by electricity generated from a grid or from photovoltaic panels. Other systems have been built with solar water heaters. There are many designs for solar hot water heater systems. Some can be as simple as black rubber tubing exposed to sunlight with water running through the tubes, and there are industrially manufactured solar water heater panels that provide maximum solar heat for the water. The individual designer can choose which system would work best for theirs and mesh best with the ecological ethics and resources. Two common questions with aquaponics are what types of fish and what types of plants. The most common fish used in aquaponics is the tilapia fish, sometimes called St. Peter's fish. There are actually many species belonging to the genus Tilapia. Some are better for fish farming than others. The species called Tilapia joca is a common type of tilapia due to their relatively peaceful nature. The genus Tilapia has two major characteristics that make it a good fish for farming. First, tilapia are a very hardy fish, able to live in a variety of water conditions and adapt well to changes in those conditions. Secondly, tilapia are omnivorous and they can live off a variety of vegetation. They are also edible and tasty. All these factors combine to make the tilapia fish an excellent choice for aquaponics systems. Of course, you could grow other fish if you wanted, but you would have to make sure your system provided the correct type of environment and provided any necessary dietary needs for the fish of your choice. Meeting these demands may require your system to be more complex and resource consumptive, thereby reducing its quote-unquote sustainability. While fish are the main crop, they are not the only option. As long as conditions are right, you could also possibly grow other food animals such as crayfish, frogs, prawns, or river clams. In fact, the more biodiversity, the more robust the system, and the better your diet, so I would encourage seeding your aquaponics system with a veritable menagerie of appropriate animals. The question of plants is at the same time a little more complex and a little more simple. There are three things you need plants for: to clean the water, to feed the fish, and to feed the humans. For this reason, I recommend your aquaponics system have 2 ponds for plants. The first pond should be dedicated to cleaning the water. What types of plants are best for cleaning? Here the answer is much more simple than people usually think. In nature, biodiversity is strength, and therefore the greater the diversity of plants in your system, the better. To seed the cleaning tank, I recommend you collect mud, water, and every type of plant you can find from local water sources. Collect the plants and place them in your system, and don't be afraid to add more plants as time goes on. Second, you need to grow food for the fish. Tilapia can subsist off a diet of duckweed and algae. Duckweed is a simple little plant, sometimes called water lentils, which look very similar to small lily pads that float on the water's surface. Duckweed has 2 characteristics, making it an ideal food source for an aquaponics system. For one, duckweed is a protein-rich nutrient source. Second, they reproduce prodigiously. It is their rate of reproduction that makes them quite a nuisance for many waterways, but excellent in an enclosed aquaponics system. To seed duckweed, all you need to do is find some growing in a natural body of water and dump some of it into your aquaponics system. The duckweed will do the rest. The duckweed will inevitably spread throughout your system and become a prolific food source for the tilapia fish. Although you may have to scoop out duckweed periodically, it is noteworthy that in Southeast Asia, duckweed is also dried out and ground into a protein-rich flour eaten by humans. Be careful, the duckweed in your system cannot gain access to local waterways, or it could spread and become a nuisance. Tilapia can also eat algae, which will grow naturally in the fish pond, but there are structures you can build in the tank that will promote the growth of prolific crops of algae, which can then be harvested and fed to the tilapia. Tilapia fish will also eat bugs and larvae that will inevitably volunteer for your system. The cleaned effluent from the third tank can then be plumbed to enter a series of long, shallow troughs or short tanks filled with a growing medium such as vermiculite or pea gravel. You can then plant various vegetables in the troughs and design them so that the excess water flows back into the fish pond. If you wish, prunings and clippings from the plants can be simply chopped up and recycled back into the system. A truly progressive aquaponics system can be integrated with other sustainable water systems. Rainwater attachment can help recharge any lost water in the system. Gray water systems can help bring new nutrients into the system, and the aquaponics system could be hooked up to an irrigation system to provide nutrient-rich water for permaculture crops planted in the ground or in container gardens. If integrated into a rigorous living machine, an aquaponics system can take in gray water, grow fish, plants, and eject clean, drinkable water. A truly elegant and well-designed aquaponics system can provide food and water able to support a person in a healthy and sustainable way. Whenever I see reports of people starving and dying of thirst in third world countries, I think of how valuable these systems could be around the world. Even in our country, these systems can provide a panacea of healthy food and water, reducing our resource consumption, bolster the ecological strength of our infrastructure, provide local healthy food, and beautify our built environments. When you use the phrase tanks, many people imagine large, ugly plastic containers. This does not have to be the case. In fact, one who is familiar with the construction and installation of landscaping water features could design an aquaponics system that serves as a piece of landscaping. The beauty of the system is limited only by the imagination and craftsmanship of the designer. Here in Arizona, I've seen buildings, gated communities, and private homes that include ostentatious water features such as fountains, artificial bodies of water, and even fish ponds. When built with conventional techniques here in the arid environment of Arizona, these types of features are an insulting and ethically criminal consumption of water and resources. However, if the desire for pretty water features could be combined with aquaponics systems, then we could actually increase the sustainability and ecological quality of our built environment. When designed at the New Alchemy Institute, the standard pond was a fiberglass tank 5 feet high and 5 feet in diameter, held roughly 700 gallons of water, and produced roughly 40 pounds of edible fish annually. Each week, 20% of the water had to be flushed and replaced. If you can envision the size of the system, you can see it is not very large and it can actually be produced at the backyard scale, meaning an ambitious do-it-yourselfer could construct one of these systems with relative ease. Across America and in other countries, notably Australia, there are many people creating and experimenting with backyard aquaponics system. Personally, it is the development of backyard scale systems I find most intriguing as the most powerful application of aquaponics. Yes, one needs to study some design techniques in care feeding of fish and plants to run a successful aquaponics system, but overall, it is not difficult to learn these techniques. Food production and water reuse are cornerstones of the creation of a sustainable society, and I always say that education and elbow grease are the necessary components for a sustainable future. Imagine if the hundreds of millions of homes in America all integrated an elegant aquaponics system, provided fish and fresh water for its inhabitants, and increased the ecological activity of the structures. With education and a little work, this goal is obtainable. You yourself could study these systems and build your own aquaponics system as a unique and beneficial part of your home's landscaping. To learn more about aquaponics, you can visit these websites: oceanarcs.org, backyardaquaponics.com, aquaponics.com.au. Thank you. The end.